Hello, this is the first video in the Game Theory series for OCR Discrete Further Maths. In this, we introduce game theory and look at payoff matrices and play-safe strategies. So game theory is a study of strategic decision-making. Specifically, it is the study of mathematical models of conflict and cooperation between intelligent, rational decision-makers. Game theory is mainly used in economics, political science, and psychology, as well as logic and biology, to analyse decision-making between two or more competitors. It is deductive reasoning, trying to avoid worst-case scenarios, possibly by collaboration, and trying to outsmart each other in either the short or the long term. Let's consider a game which we may well have all had a go at some point in our lives. Rock, paper, scissors is an example of a two-player zero-sum game. Two-player games, well, only two parties can play. And a zero-sum game is one in which one person's gains exactly equal the net losses of the other participant or participants. Hence, collaboration is not advantageous. A payoff matrix is a table of outcomes to reflect the game as ordered pairs or as a matrix. So the payoff matrix is given from the point of view of player 1's winnings, unless otherwise stated. So player 2's winnings would be the negative of these. So for the rock, paper, scissors game, if you have both of you showing rock, neither wins, and therefore it would be a zero score. However, paper wraps rock, so if the first player was rock and the second paper, they would lose. However, rock blunts scissors, so if the first player played rock and the second scissors, they would win. If the second player plays rock when the first player plays paper, because paper wraps rock, player 1 would win. If they were both paper, it would be a draw or neither would win. And of course the scissors cuts the paper, having a -1 there. If player 1 plays scissors, then they will be blunted on the rock, they will cut the paper, and if the other person plays scissors, then again neither win. Here's Sue's payoff matrix for a different zero-sum game against Jim. What is the outcome if Sue plays strategy A and Jim plays strategy X? Well, by looking at the cell in the payoff matrix, which would be AX, we can see that Sue wins 3 and Jim therefore loses 3. So what's the worst that could happen for Sue if she plays strategy A? We can see that if Jim plays strategy Y, Sue could lose 2 units. Generally speaking, players want to avoid the worst case scenarios. A play-safe strategy is choosing the option with the smallest potential loss. So each player looks at the worst results for each choice and chooses the least worst. People often ignore the riskier option and go for a play-safe option. If we find what they call the row minimum, then looking along row A or strategy A for Sue, we can see that -2 is the worst option there, and that 0 is the worst option if she plays strategy B. Remembering that Jim's winnings are Sue's losses, and that this matrix shows the winnings from Sue's point of view, we can see that we're looking for maximums down the columns to check what would happen for Jim. So the column maximum is 3 for strategy X and 1 for strategy Y. These column maximums and row minimums reflect the worst case scenarios for Sue and Jim. So then, trying to identify Sue's worst potential loss, that would be -2. So if we look for the maximum of a row minimum or the row maxi-min, that would be 0, strategy B for Sue. If we look at Jim's worst potential loss, that would be to lose 3. And therefore, we're looking for the minimum of a column maximums, or the minimax, and that would be best here for Jim to pay strategy Y. So what we're saying is that the Playsafe is the row maxi-min for Sue, or strategy B, and the Playsafe is the column minimax for Jim, or strategy Y. So let's work out the Playsafe strategies for this game. You may wish to pause the video here and do this for yourselves first. Remembering that we want to look for the row minimum and the column maximum. So the row minimums are going to be -2, -1 and -2, while the column maximums will be 3, 4 and 2. We then want to look for the maximums of the row minimum, so the maxi-min, which would be the -1, indicating that player 1 would be better with strategy Q. And we look for the minimum of the column maximums, which in this case is the 2, indicating that player 2 should play strategy Z. If player 1 knows that player 2 will play safe, in other words choose strategy Z, should player 1 adopt a different strategy? Well, looking at the payoff matrix, player 1 would do best by playing strategy R if they thought player 2 would always adopt strategy Z, because then they would always win more points, i.e. 2 points each time. Working out the Playsafe strategies for this game, again we're looking at the minimum of the rows, in which case we would have -1, -2 and -3, and the column maximums, which will be -1, 2 and 3. So here we have that the row maxi-min is -1 and that the column minimax is also -1. So in this case, player 1 would adopt strategy P and player 2 would adopt strategy X. Even if player 1 knows player 2 will play safe, i.e. strategy X, they will still choose to play strategy P. So in this case it's slightly different to the last example, in that even if player 1 knows that player 2 will play the safe strategy, they will still make the same choice rather than thinking of a different choice. We will investigate these ideas further in video 1.2 on stable solutions and dominance.